And now we are moving to the last talk of this session with Pim Kat, the president of Technobis Group, and he's gonna talk about commercializing PIC technology for sensing.
Thank you. This is not Valencia, as you can see. It's just a picture of my holiday. I couldn't find something that I didn't have to pay for this presentation, so I made it very cheap. About the company Technobis, we have three sections in our company. TSS is a system supplier producing optical instruments for OEM customers like Perkin-Elmer, Nikon and other big companies. TCS is an OEM company itself. It sells crystallization research instruments. All those instruments are classic optical instruments. And the last section, IPS, Integrated Photonic Sensing, as the name says, is all based on integrated photonics. And that's a combination of the chip technology that we use and the packaging that we had to produce. You see in the line underneath some of the work that we do, engineering, assembly, testing, research, validation, packaging. On the handouts you can see a very nice purple picture of this module that we produced in 2010, I think. On your handouts you can see two devices. One is a big box, that's a Mach sender interferometer that we produced to get the resolution down to femtometer wavelength shift resolution. And the picture also shows a device on my hand, and that's the integrated photonics device. That is incredibly smaller, but also incredibly more resolution. We got in one step from around 30 femtometer wavelength resolution to 0.4 femtometer resolution just by putting the device on the chip. And the weight reduction was about 8 kilo compared to a Mach sender interferometer fiber-based to the chip-based system. And that was basically the first step that we did in integrated photonics. We are developing state-of-the-art solutions, and we provide complete solutions to our customers. And since the last 2 years, we only do integrated photonics devices in IPS. We try to focus on some markets because sensing, strain sensing, temperature sensing is everywhere. So we try to focus on medical devices and aerospace, pharma, high-tech systems, energy and mobility. And that's already a lot, but you don't see things like a railway or bridges or wind turbines. So this is what we did. We developed the chip technology in our company, and it's all based on fiber break grating sensing. I think there's a picture later on explaining the technology a little bit. We use fibers for sensing. We put fiber break grating sensors in the fiber, and we read them out with optical chips. This chip is actually the first chip that we ever developed. It's 3 spectrometers on one chip, and the larger one on the picture should be the best one, and it was the best one of the 3. This one was a first time right design, almost, and that only happens once. After that we never got the success of making a chip design and then having it operational in the first run. So this reduces the size of the instrument dramatically. This red box that you see here is only 300 grams. It's about 10 by 10 centimeter and 2.5 centimeter high, and able to read out FBG sensors up to the number 32,000 sensors in a couple of fibers. Packaging, we started doing this chip technology, and then we found out that there was only one institute able to package our chip, that is Tyndall in Cork, Ireland. But that's more or less a university, so high volumes cannot be done there. We had to develop our own packages. Thermal control of the chips is extremely important to do this extreme high resolution sensing. So we developed a complete line for packaging of our chips, and it's now opened up to third parties starting in integrated photonics and don't know where to package in high volume. So we can package at this moment to volumes of 250,000 units a year per application. Integrated photonics, yeah, you can probably find it everywhere in the future. So consumer electronics, agri and food, datacom, telecom, industry, military and aerospace, healthcare, IoT, and probably also for your business. Again, we are trying to focus on a couple of markets because it's too large. If you see the ramp up and the planning of what people think what will happen in 2005, the sensing or the photonics sensing was estimated on 228 billion euro, and now we are already talking about 615 billion euro for the complete market. So people are expecting this technology to grow even more than we could think of a couple of 10 years ago. For our company, it means that we are growing tremendously. We started this technology with 23 people, and we are now over 70 people already. And most of the new people are all in integrated photonics sensing devices. For us, if we see what applications we are doing in medical devices and aerospace projects, we are ramping up to over 100 million turnover in the next years. So growth is really an issue in my company. I think we are most famous in our aerospace program. We do a lot of trials and test flights on all kinds of aircraft, helicopters, fixed wing aircraft, drones, and military fighter jets. In turnover, it's not the larger part of the company. Medical devices is much larger. But unfortunately, I'm hardly allowed to tell anything about the medical device application. So we always focus on the aerospace. High-tech industry is something from our background. Companies like ASML, FEI, EVG, and so on are using our technology to measure things in their machines, and that's a heritage that we have from the past. And energy is something new. We developed a device for wind turbine monitoring in the last years, but also radiation measurement, heat flux sensing in fusion reactors. Okay, the technology that we use, fiber brake grating. It's a grating that is written in the fiber, in the telecom fiber itself. The grating is reflecting one specific part of the light, and the reflection is measured with an instrument called an interrogator. And you can imagine that if you stretch the fiber, that the wavelength that is reflected will shift also. And that's what we measure. So the chip that you see here is the first chip we produced. It's a spectrometer on chip measuring the wavelength shift. If we want to go down to higher resolutions, we use Mach-Zehnder interferometers to measure down to resolutions of 10 attometer wavelength shift. Well, of course, using integrated photonics makes things not easier, but a lightweight, a small volume, and a lot cheaper than what we had before. Well, this is the roadmap on integrated photonics. We started with a device first concept in 2010. The first Gator chips were produced somewhere around 2012. The metal housing that you see on the top is space qualified, hermetically sealed package that we put in the demonstrator for Airbus. 2015 we had the first real sellable device ready called the Gator. 2016 the package on top, the bluish one, is the dual PIC package for landing gear monitoring on the A320 aircraft. That is prototype now. The real landing Gator is down there. That's a 6-chip device measuring redundant on every landing gear on the aircraft. So it's 6 interrogators measuring 3 axles on the landing gear. 2017 we had the Gator ready. That's a very miniature FPG interrogator. Even I think it's almost half the size of the red box that you see. This one was produced for the Eurofighter, has been on a flight test. Since this year, last year, we have the Gator. That's an aerospace compliant instrument for helicopters and drones, with complete computer on board, storage on board, wireless interfacing, and so on. And within the program PICSAP, we are now building a demonstrator with a complete system again in one package, meaning that we have the sensor chip inside, we have the light source, our own light source inside, we have an optical switch, solid state optical switch inside, and the front-end electronics is also in this package. And that should be ready end of this year, probably. Some applications are already asking for well, what we call the normal use, the standard use things that we will all have in the future. An app on your cell phone that says something about, well, things in your car or other nice stuff that we do. About the chips that we produced, we started doing what we call, we all gave our chips very funny names. So the Palawan Maze is the most sensitive device that we produced for ASML. It's one of the first chips that we did. With the resolution, first shot was 0.4 femtometer resolution. And we even got it on 100 Hz sampling frequency down to 10 attometer wavelength shift resolution. Standard is for standard strain measurement, 1 picometer equals almost 1 microstrain, so 1 micrometer per meter resolution. That's for standard systems mostly used. You can see that we produced chips with a better resolution, almost a factor 10 better resolution every time. The green ones are all operational and available. The red one is what we call the pain in the ass chip. It is not functioning after I think 7 runs already. The nice thing is that we can use our chips also to a better resolution, and the Lady Gator chip can be used in a less accurate region, so we can cover this complete region. But this is one of the chips that, well, doesn't come out as it should. There are 2 devices scanning on a very high speed. 1 megahertz Super Gator is now being tested at Airbus, and that's mainly focusing on monitoring composite materials, so monitoring of delamination, lamp waves, impact detection, and acoustics. Those are prototypes, and the Medigator is a photoacoustic imaging device measuring at 10 megahertz sampling frequency. In a combination, the sensors are not FBGs anymore, but ring resonators in a catheter. Well, for us it means that we have all the building blocks ready. So we have our own light sources, we have the sensor chips in all kind of variations in resolution. We have electronics, high-speed, low-speed electronics. And it means that we can, well, we compare it to playing with Lego. We have the building blocks ready, and if you combine them in another way, you can build whatever you like. So the Gators, the Aero Gators, the basic Gators, switched Gators is switching over multi-channels. Industrial switch rev Gator has an absolute reference inside, so it's for absolute measurement. Landing Gator is the six devices in one unit. And the Gator is the standalone unit that is now flown on a drone at Airbus. When we started this technology, the first device that we built was called the Mincis. That was still free space optics, so spectrometer and a light source combined in one box. And if you look at the price of the interrogator, we were talking about 50k euro for an interrogator. At this moment, the Gator systems based on integrated photonics is around 5,000 euro. And we have a research program for extreme low cost interrogators, and that means a bill of material of 50 euro for a complete interrogator. The same happened with the price per sensor. So if you divide the interrogator by the number of sensors that we can read out, and you add the price of a sensor to it. Some years ago when we started, we were at 1,500 euro per sensing point, a combination of the sensor itself and the interrogator. At this moment we are around 50 euro per sensing point, and basically it's a combination of making this integrated photonic devices but also getting the price of the FBGs down. We are now talking about series production of FBG €1 per sensor. And when we started this technology, it was 250 euro a sensor. So technology also helps on that side. And for us, it's ramping up the volume. So when we produce some 500 units in 2017, we will probably do some tens of thousands of units this year and ramp up to something like 250,000 or even more devices in the next years. You can imagine getting this price down and getting the weight of the system and the power consumption down. It opens up complete new markets for us. So we are now talking about automotive use, not only in Formula One racing, where we are now, but in the future in every car in the world. So basically what we see with our customers, we are designed in some aircraft at the moment. It means that we cannot retract anymore. We have to deliver the systems. In 2023, our system will be in every Airbus A350 aircraft. Landing gear probably 1 year later in all A320 aircraft. So it's really happening now. Medical devices the same. So if we add up the turnover of those projects in the next years, we see that we are going to grow to a 100 million plus company. But we are approached almost on a weekly basis by companies that has some other application for strain sensing or temperature sensing or pressure sensing. So we don't know what's going to happen. We can see what we have in our portfolio at this moment, but there are new projects coming in on a weekly basis almost. So we think in 2023 it must be more than 250,000 systems that we will deliver, and more than 160 million turnover on the applications that you can see here. So it's not only aerospace and medical anymore. We are in racing. We are in the most expensive luxury yachts in the world. They all have our equipment on board now. And we started some projects in automotive, and that's mainly focusing on the extreme low price of interrogator systems. An overview of our aerospace roadmap. We started a project in 2008-09, helicopter blade monitoring with Boeing. Boeing was the first company interested in this fiber brake grating technology on the blades. And we promised them to reduce the size and the weight and the cost of the interrogator down to, well, a couple of €1,000, a couple of 100 grams. To be able to implement the measuring system inside the blade of an helicopter. Well, that one is flying already for 2 years now. We started very soon after that a Dutch program, TAPAS, that's thermal plastic composite material monitored with our interrogators, and you can see that We did TAPAS 1, TAPAS 2, and we are starting this year TAPAS 3, and that is called Intelligent Thermoplastic Material. Saristu has been a very large European program where we could do 4 demonstrators in one program. They were all successful, and I think that was the reason why we were approached by Airbus, Boeing, Embraer, and Bombardier, because this is really unique. The size and the weight and the power consumption, resolution, and the number of sensors that we can read out is really unique, especially if you look at the price of the system. We started now 2 new programs. Algesmo is the landing gear, Extreme is composite material. You can see what the aim of the project is. It's a demonstrator, or it's a flight test, or it's on a helicopter or a fighter jet, or other applications. But the end of the project is mainly now things that are really used. So not only the European project and having a demonstrator, but having a real product in the end of those programs. So at this moment, I think we have 7 or 8 projects running, and most of them, or a lot of them, are European funded, co-funded projects. Okay, then about packaging. We started packaging for ourselves. We developed what is called a generic test package. That's well, a standard package where you can put in your photonics chip. If you want to use it and keep it in a good shape, it's better to package the chip than has it loose on the table. So we produced our own packaging. We started packaging for our own devices, but a foundry like this is a 550 square meter foundry with about 6.5 million equipment inside, and that's a little bit too expensive for only my product. So we are opening up the foundry for other users. So it's not only sensing, it's also telecom, datacom. Not the integration of chip to chip. That is something that is better off with FIX in Enschede. And the real high speed packages, we always say go to Lingra Cordon with that, because that's not our specialty. Specialty is high resolution and a very accurate control of the chips thermally. At this moment, we did up to now 140 PIC designs, meaning that we are almost on every MPW run that's available, and we will start a silicon run this month. I don't know if you've been contacted about that already, Timo. We have produced about 23,000 chips already in the last years, and developed the packaging lines and packaging processes for that. So it's really filling up, and a lot of work getting into the company, and that's mainly the growth from 23 people to 72, I think, today, in only 2 years' time. So packaging is for sensing, not the wet stuff, so we don't like lab on the chip applications. I want to keep that out of our clean room, but sensing in the broader sense, looking at wavelength shifts or phase shifts. That's basically what we do. We do a lot of datacom and telecom packaging for customers or startup companies or the larger worldwide companies. And one of our specialisms is hermetically sealed packages for aerospace and space applications. Well, this is how we help people to start. We started integrated photonics about 10 years ago with a lot of IDs, gyro on chip, interferometer spectrometers, bare die pressure sensors, and so on. We skipped them all. We are handing them out to companies that are starting in integrated photonics and have an ID. For instance, the gyro on chip. We have it in prototype, but we are offering it to a Dutch company to pick it up from there, because we did 3 iterations already, and we are not going to finish it anyway, because we're already drowning in work as it is today. So we help doing the basic chip design. Final chip design is always done by a design house, like for instance VLC. Then we run the MPW runs, mainly now indium phosphide chips, but we will definitely start this month doing silicon chips. Then we get the chip back and test it and start packaging. And for us, it means we have the device, the module ready for our interrogators or for customers. We build the modules for them. So quality control, fiber alignment, fiber array alignment, wire bonder, die bonder, curing, thermal management. That is what we typically do in these designs. Yeah, this is a lot of our customers. It's mainly in aerospace and in medical devices. It's all about reliability. So we did a lot of tests together with Thales, ESA, and a lot more. We had a workshop on reliability of integrated photonics chips. Yeah, that's necessary to ramp up and to really get our instruments in aircraft, satellites, and medical devices. Thank you.
Thank you very much for your nice talk. Are there any questions from the audience?
Hi, thank you very much for this talk. I have a question regarding the number of FPGAs that you can interrogate with just only one interrogator.
Yeah, it's a device that we had to come up with for Airbus because we had a flight test with what we call the standard solution, only a couple of FPGAs in one fiber, and that means you have to run a lot of fibers parallel with the section of interrogation. Then we got the question, can you put all the sensors, all 2,500 sensors in one fiber? I said, well, probably not. And then the project manager of Airbus made me believe that there was a solution at the competitor. So I went home, started thinking, and by making a combination of wavelength multiplexing and time multiplexing, and using 6 different light sources in our interrogator, we now have sections of 5 meters in one fiber, and every section has something like 200 sensors in it. So we can now put 2,500 sensors in one fiber. Okay. And the distance between the FPGAs can be 0 or 1 meter or 10 meter or 100 meters. So doing that with multiple fibers as we have it now in the aerospace application means that we can at this moment do in our prototype 32,000 sensors in 16 fibers. Yeah.
Okay, thank you very
so
much.
for instance, for parameter monitoring or pipeline monitoring, yeah, you can make tens of kilometers sensor devices, and knowing that one FPGA is at this moment only €1, yeah, it's definitely competing to the Bruen or Raman scattering devices. They cost around 70,000 to 140,000 euro, and this is a device of well, 14,000, 18,000 euros, something like that. So we definitely think there will be an interest for a very long distance monitoring.
Okay, nice. Thank you very much for the information.
Are there any other questions?
Hello, my name is Justina Agren. I'm representing company SDS Optic, and we are developing the medical devices. So my question is about the medical application.
Okay. Well, I think I am allowed to say that we are doing minimal invasive instruments, mainly guide wires, catheters, endoscopes. And what we measure is, for instance, tip force of the guide wire, temperature in the tip, shape reconstruction of the complete catheter, so 2.2 meters, and knowing exactly where the tip in your body is within a radius of 1 millimeter accuracy over that length. Did I mention pressure, temperature, shape, and force? And that's what we do in medical devices. Mostly we use multi-core fibers to do that, so the 7 core fibers to put all FBGs in one fiber.
Okay, so if there are no more questions from the audience, let's thank Pim again. And all the speakers from the session. And now Sergio Saez will explain a little bit, well, briefly, the business-to-business session that will be held now. Well, after lunch, not now, at 2:30.
Hello. We are close to the lunch. That's very good news. Okay. My name is Sergio Saez. I will be responsible for the B2B meeting sessions during these 2 days. There will be, you received an email yesterday night. I expect all of you. We will have 3 sessions. The first one after lunch. Second one is from 6 to 7:30 today. And the third one will be tomorrow from 3 to 4:30. We have 5 available rooms, but in case you need any other meeting to book, just tell me, and I will look for another place. You can take a look of the pre-booked, the distribution that I made with your requests, and I expect. I think I covered all your demands, and for the next, well, after the lunch, for the next 90 minutes, we will have 15 meetings, 30 minutes duration each one. And as you can see, we have 5 rooms. It's in the next building. At 2:25 in the registration point, you will find me, and we will go together to the next building, to the rooms. And we have these rooms: Escoge, Resuelve, Descubre, Debate y Aprende, and the 3 slots of 30 minutes. Those of you who want to book another meeting, but and they have available time, just tell me, and I will look for places to meet. Okay. Thank you very much. And Sergio Saez, I will be during the lunch in case you need something. Okay, thank you.